Hello everyone, I am Professor Minhua SHAO from Department of Chemical and Biological Engineering, also Hong Kong USD Energy Institute. I am the founding director of Sustainable Energy Engineering program. So today I'm here to give you a brief introduction of this program. So the Sustainable Energy Engineering program was launched in 2017-18 academic year by School of Engineering. So the first cohort made the declaration in 2018-19. So that means they are now in year 3. So the SUSEE program is not like a traditional program. It's actually an interdepartmental program based in School of Engineering. It's managed by Department of Chemical and Biological Engineering and supported by 3 other departments, including Department of Civil and Environmental Engineering, Department of Electronic and Computer Engineering, and Department of Mechanical and Aerospace Engineering, and also the Hong Kong USD Energy Institute. So it will be accredited by the Hong Kong Institute of Engineers in 2 years, so after the first cohort graduates. The target enrollment for this program is not big, it's about 30 students. The first cohort actually about, we have 15 students. So everyone probably have heard about the energy and the energy crisis. So we need energy. It's required for the effective and efficient operation of our society, from provision of utilities like electricity, gas, water, communication, to transport, to schools, hospitals, office, to factories. So we all need energies. So actually, energy is listed as the number 1 in the top 10 problems for the next 50 years. So probably you will argue that we still have the sun, right? So the solar energy is endless. You can utilize the solar energy. But the problem here is that how do you utilize the solar energy and how do you store this solar energy? So the energy consumption these days, if you take a look at this chart, the energy consumption increased significantly since the Second World War. And the primary increase is coming from the fossil fuels, including the coal, oil, and gas. That contributes about 80% of the total energy supply. The problem of the fossil fuels is that it generates the carbon-based material, that's the carbon dioxide. And we know that carbon dioxide is one of the greenhouse gas. Probably you have heard about the greenhouse effect. Basically, the average temperature of the Earth will increase because of this greenhouse effect. The energy from the sun will enter into the atmosphere and then absorbed by some of this greenhouse gas. And then it will released again back into the Earth, so that it will increase the temperature. So the greenhouse effect will cause a lot of problems, including the melting of the ice and increase the temperature of the Earth, and will cause the severe climate change. The other problem with the fossil fuel is that it also generates other air pollutions, okay, like sulfur-based and nitrogen-based compounds. So these are harmful to the human health. So probably you have learned this kind of smoggy environment, okay, in most part of China. And actually in Hong Kong, we also have this kind of power plants. So this one is actually from the Namad Island. It actually uses natural gas to generate electricity. So it's not from coal or gas or oil, but from the natural gas. But natural gas, we know it also contains carbon, right? So it also generates carbon dioxide into the atmosphere. The third problem, of course, the fossil fuels. Actually, it has a limitation, right? So the resources of the fossil fuel is not limited. So once we consumed more, and then the resource, of course, will be empty in the end. So we need to develop or utilize some of the clean and sustainable energy. Some of the sustainable energy resources, including hydroelectricity, solar energy, wind energy, wave power, geothermal energy, bioenergy, tidal power, nuclear energy. So some of this is renewable energy. Actually, we also have installed in Hong Kong, for example, the solar panels. We saw some of the actually on the top of the roof. You can see these solar panels and the wind turbine. So this is one of the example from also from the Nama Island. There's a one wind turbine installed. Okay. But the problem here is that a lot of this the renewable energy is intermittent. For example, the hydroelectricity. So it can continue to generate the electricity, but you cannot use them, and you need to find a way to store them. For example, in Yunnan province in China, more than 80% of the electricity will be wasted because it cannot be consumed, right? So you need to find a way to store this energy. For another example, the solar energy, wind energy, they're all intermittent. Okay? During the daytime, you can use the solar energy to generate the electricity, but you cannot during the nighttime. But the requirement of the electricity is actually all day long. And we cannot just using the electricity during the daytime, right? Not at the nighttime. So we need to store this electricity when they generate it, and then release it when you use it. So that's come out to the energy storage problem. So before that, I just want to introduce Hong Kong actually also trying to promote this renewable energy. So one example is the CLP promoted this renewable energy feed-in tariff. So if you install the solar panel or the wind turbine in your house, actually, and then successfully connect into the grid, actually the CLP basically buys the electricity and pay you at a higher price than the market. So there are different forms of energy storage medium. First one, probably you're all familiar, is the chemical energy storage. So like the coal, the oil, the natural gas, they're all chemical compounds. So they store the energy. There are some ways probably you are not very familiar, like hydrogen, like a biomass. The hydrogen is a much better chemical than the natural gas or coal because it does not contain any carbon. So it will be completely clean when you use the hydrogen. The biomass also is a better choice because it actually generates a carbon neutral cycle. Okay, it does not generate more carbon. The other ways of store the energy is mechanical energy storage. For example, you're using the fire wheels, you're using the pump, using the compressed air. You also use this hydro pump power plants. So the hydro pump power plants is also an interesting concept because we know that the price for the electricity during the daytime is actually different from this nighttime. So you can use the electricity at a cheaper price to get the water from the low level to the high level. And when the price of electricity is high, you're using that water at the high level to generate the electricity. Okay, so that you can take the profit. So this process is actually with a high efficiency, more than 80%. The third form is the thermal energy storage. One example that you can see from the picture is the solar thermal panel. So basically, these collect the energy from the sun and then heat the hot water. The fourth one is the electrical energy storage. So this is quite challenging because it's very difficult to store the electricity in a media. One of the examples is the capacitor, but the capacitor, we know that we only store the charge on the surface, so it's very limited. unless that you develop a superconductor that does not lose any of the energy when you store the electricity in a grid. The last one, we talk about the electrochemical energy storage. This one you also are familiar with because of the one of the typical example is battery. So using because this storage reaction involves the electrochemistry reactions, we call the electrochemical energy storage. Of course, there are other types of electrochemical energy storage method. For example, the supercapacitor, for example, the fuel cells, for example, the electrolyzers. So electrolyzer, actually you can use the electricity to split the water into hydrogen and oxygen. So basically you store the electricity into a chemical compound, hydrogen. So those will be learned in this program. So let's look at the energy issues in Hong Kong. We know that secure the energy resources are essential to power buildings and the public transport system. And we know Hong Kong has no energy resources, right? Especially for the traditional energy. Of course, it has some of the renewable energy resources like solar, like wave power, tidal, or wind energy, but that has not been developed yet. And it has to import all primary fuels like oil, gas, coal to meet these energy requirements, but also facing the pressing challenge of local air pollution and global warming leading to climate change. So it has been said that the air pollution caused more than 3,000 premature deaths and loss of 39 billion Hong Kong dollars in 2013 alone. So we have to think about how to solve this problem by utilizing more renewable energies. Actually, there's one example that I think has to be highlighted is that the promotion of electric vehicles in Hong Kong. So this picture is showing the Tesla. That's the fully electrical vehicle. So 2 years ago, the Hong Kong government actually has this kind of tax rebate. So when you buy the electrical vehicle, you do not need to pay tax. So that's at that year, I think the Tesla as an electric vehicle is actually the number is the highest among the single any of the model. So Hong Kong government actually follow a lot of this the policies and the government issued a lot of new policies regarding the energy efficiency and also the environmental regulations. But all these policies require the input from the energy engineering. So what we can do as the energy engineer? So first, we can implementation of suitable energy policy emission reduction requires professional energy engineers to address the energy scarcity and to combat the energy-induced pollutions and carbon emissions leading to climate change by developing innovative energy systems and technology that can produce clean, renewable, and sustainable energy, and enhance the energy generation, efficiency, utilization efficiency, and advance energy storage capability. And also critically examine various initiatives and measurements to improve the energy efficiency and reduce the energy consumption. Last is driving practical solutions taking into consideration of the cost, safety, benefits, and sustainability. The objectives of this new program, the Sustainable Energy Engineering Program, is to develop leading professionals who can design and implement energy systems to respond to expanding global environmental and energy needs. So our mission is to provide a strong multidisciplinary curriculum in energy engineering that will prepare students for careers focusing on the energy solutions, including energy generation, delivery, storage, and efficiency. So the unique feature here, I listed some of the unique features of this this program. First, it focuses on both traditional and renewable energy technologies, and also the interdisciplinary curriculum to teach fundamental knowledge of power generation, conversion, distribution, consumption, optimization, and management. So you can basically have a very general understanding of the energy conversion and storage, and also can focus on several specific energy technology like solar energy, wind, and hydropower, batteries, and fuel cell. We have a lot of elective courses in this area, and also the sustainable energy laboratory that we specially designed for this program. This program also has exposure to multiple engineering disciplines, not only the energy, including the chemical, civil, electrical, building, mechanical, materials. So all this, the students can learn a lot of knowledge from these disciplines. We also provide abundant internship and industrial training opportunities. So this actually will be provided by all 4 departments, not only from the chemical engineering and biological engineering. We also provide a special designed sustainable energy lab courses, also will be offered by 4 departments. For example, the chemical engineering department will offer the fuel cells and the lithium battery lab courses, and the electronic and the computer science engineering will offer the solar energy lab course, and the mechanical engineering will offer this hydropower courses lab. So this is an overview of the curriculum structure. Basically, the first year students will take the engineering fundamentals, including the physics, chemistry, math, and computers, and of course some of the introduction courses. And then from the second year and the third year, we take the energy core courses. So a lot of these core courses were from the different departments. For example, MECH is mechanical engineering, CENG is chemical engineering, ELEC is from the electrical engineering, CIVL is from civil engineering. So all these core courses were offered by different departments. And also we'll take the energy policy courses were offered by our policy division. So we also have our own courses. The course code is the ENEG is from our own courses. After that, we will provide a lot of elective courses, and we divide it into 4 categories. Category 1 is energy generation. Category 2 is energy storage and distribution. Category 3 is energy utilization. And category 4 is sustainability. So each student have to choose at least 1 from each category, and the total credit is 18 credits. We also recently introduced an investigation project. So that means if you're interested in conducting research, you can take that as a elective course. And of course, the final year we have to conduct the capstone project. We have a lot of supervisors that can supervise students to take this kind of research-based projects. And also we have about 120 hours of industry training that will be offered in tailored designed in Polytech University of Hong Kong. So as I mentioned, so this program also will be supported by the Hong Kong University Energy Institute, and the curriculum design especially is supervised by the Energy Institute. So we have a lot of expertise in this institute to support this program. Here I just list several, some of the potential employers from the government, from the public utility and service, from the private sectors. So those are listed in red, highlighted in red. Actually, they are the diversity board members for this program. I also listed some of the academic advisors for students from the chemical and biological engineering, from the mechanical engineering, from the electrical engineering, from the civil engineering, from the chemistry department. And so it's a very interdisciplinary advisory team. So students can choose any of them as their academic advisor and talk with faculty. So if you have any inquiries, you can contact me by email, by phone number, and welcome if you are interested. Thank you.